All right, let's get into it. You've probably messed around with chatbots that can, talk. But what if software could actually do things for you? That's what we're talking about today, AI agents. These are systems that can actually get tasks done, all on their own. We're going to break down how they're designed, how they work together, and, this is crucial, how to build them safely right from the get-go. I mean, really think about that for a second. What if your software wasn't just sitting there waiting for you to click a button? What if it was a proactive partner already figuring out what you need and handling complex jobs all by itself? That right there, that's the whole promise of AI agents. So, okay, what exactly is an agent? Well, at its core, it's a system that uses a large language model, an LLM, as its brain, its reasoning engine. But here's the real kicker: autonomy. This isn't just about responding to a prompt you type in. No, an agent manages a whole workflow. It makes decisions, it course corrects when things go wrong, and it sees a task all the way through to the end. And let me tell you, this is a massive leap beyond traditional automation. Think about old school automation. It's like a super rigid checklist, right? If one little thing is out of place, the whole thing just breaks. But an AI agent? It's more like a seasoned investigator. Let's say it's looking at potential payment fraud. It's not just blindly following a set of rules. Nope. It's evaluating the context, piecing together subtle patterns. It's navigating all that ambiguity with a kind of reasoning that feels, well, almost human. Okay, so how do we actually build one of these things? Let's dive into the blueprint. Turns out, every agent, no matter how complex it gets, is built on the same core components. It really just boils down to 3 key parts. First, you've got the model. That's the brain, the thing doing all the thinking. Then you have the tools. These are his hands, how it actually interacts with the world. And finally, the instructions. This is the rule book that keeps it on the right track. A brain, hands, and a rule book. That's the whole foundation right there. All right, let's start with the brain, the model. This is the LLM that's making all the decisions. But here's a really important design tip for you. You don't always have to use the biggest, most powerful model for everything. You can actually use a smaller, faster one for simple stuff, like routing tasks, and then only bring out the big guns, that more advanced model, for the really heavy lifting, like, say, deciding if a huge refund should be approved. Next up, we've got to give our agent some hands, and that means tools. This is where an agent gets its real superpowers. You've got data tools, which let it go out and get information, query a database or search the web. Then there are action tools, which let it do things like send an email or update your CRM. But the orchestration tools, this is where things get really wild. It means one agent can actually call another, more specialized agent as a tool. You're basically creating a whole team of automated experts that can work together. And that idea of agents working together, well, that brings us to our assembly line. Orchestration. How do we actually get all these parts, and even multiple agents, to work together seamlessly on really complex jobs? So the most straightforward way to do this is with a single agent system. You've got one brain and you give it all the tools it needs for the job. From there, it just enters a simple loop. It thinks about what to do next, uses a tool to take an action, sees what happened, and then repeats that cycle over and over until the task is finished. And honestly, for a lot of workflows, this is all you're going to need. But, things aren't always that simple, are they? So what happens when a task gets really complicated? Like with way too many if-then branches, or just a messy pile of tools for one agent to juggle effectively. That's where you bring in a manager. Seriously, in this pattern, you have one central manager agent that's basically the project lead. It doesn't get its hands dirty with the actual work. Instead, it delegates tasks to other, more specialized worker agents. Then, once the workers report back with what they found, the manager pulls it all together into one final polished result. It's like an automated org chart. Now, the other way to do it is decentralized. Here, the agents are all peers. There's no hierarchy. Think of it like a relay race. Instead of a manager telling everyone what to do, one agent finishes its part of the job and then hands off the task to the next agent in line, just like passing a baton. This is perfect for stuff like customer service triage, where a problem has to move smoothly from one specialist to the next. Okay, we've got our blueprint, we've got our assembly line, but hold on. Before we even think about putting this into the real world, we have to deal with the single most critical step, the safety inspection. Let's talk about guardrails. Because this is exactly the kind of thing you're up against. A malicious user trying to hijack your agent with what's called a prompt injection. If an instruction like this actually gets through, well, it could have very real and very expensive consequences. So, how do you stop it? The answer is a layered defense. There is no single magic bullet here. You start with a relevance classifier to make sure the request is even on topic. Then, a safety classifier looks for those jailbreak attempts. A PII filter steps in to block sensitive personal info. You've got a moderation API to flag anything harmful. Tools safeguards are huge. They put hard limits on what an agent can do, like capping a refund at a certain amount. And you can even have simple rules to block specific keywords. See? Each layer is designed to catch what the previous one might have missed. And what's the ultimate safety net? The final guardrail. A human. You. Your system absolutely has to know when to throw its hands up and ask for help. There are two big triggers for this. First, if the agent just gets stuck. It tries a few times and keeps failing. Second, if it's about to do something high risk or permanent, like approving a massive payment. When in doubt, the agent needs to call for a human supervisor. All right, we've covered a lot. We went from the blueprint to the assembly line and all the way through that critical safety check. So as we get ready to launch, let's just lock in the main takeaways. First, remember those 3 core parts of any agent. You've got the brain, which is the model, the hands, which are the tools, and the rulebook, which is the instructions. Second, remember the 2 big patterns for getting them to work together, the top-down manager approach and that peer-to-peer decentralized handoff. And last but definitely not least, the most important point of all. At every single stage of this process, your #1 priority has to be safety. Building agents that are predictable and controllable using layers of guardrails, that isn't just a nice to have. It's absolutely essential. So there you have it. That's the blueprint for building software that doesn't just talk about things, but actually does things. This is the foundation for a whole new wave of autonomous systems. So the only real question left is, what are you going to build?